Blockchain technology is revolutionizing how data is stored, shared, and monetized. From logistics to finance to retail messaging, blockchain networks are transforming industry after industry. One of the more innovative uses for blockchain technology is decentralized data management. This involves distributing the responsibility of managing data across a network of machines. It's not just about security either. Blockchain-based data management offers privacy across devices and platforms, with no single point of control or failure point that could compromise user information. As new use cases are developed in finance, consumer applications, and privacy, blockchains, cryptocurrencies, and cryptocurrency wallets have experienced a meteoric rise in popularity. Although distributed ledger technology is a great form of immutable information storage, the open-source nature of the system and the transparent data model pose an interesting dual-sided nature for user privacy. Depending on how it is implemented, this could be beneficial or detrimental to user privacy. Most blockchain protocols allow users' transactions, resources, and other data to be completely viewable by other users. Others rely on proofs based on zero-knowledge and protocols to conceal any information about the parties involved in a transaction. Blockchain and decentralized data management are closely related, but the two are not the same. Here's a look at their differences and how they work together. What is blockchain? Simply put, a blockchain is a distributed database with no central administrator. The chain analogy comes from a linked sequence of data blocks that record transactions as assets move from one owner to another. Transactions are recorded within each block chronologically and then secured with cryptographic keys for validation. Each block comprises encrypted transactions and the unique chain ID, recorded in a chain built into the application protocol. Each block contains information about the previous block and its parent, which builds up to create an encrypted dataset that can't be changed or erased. Where does blockchain fit in with data privacy? Data privacy is a concern for every business. Protecting sensitive data is a top priority for most organizations, but as we've seen with any data breaches, keeping this information safe is easier said than done. While cloud computing has intensified the issue, blockchain technology may offer solutions. 3 key characteristics of blockchain platforms. Blockchain technology is often mentioned in Bitcoin and other cryptocurrencies, but the principles apply to any distributed network that records data in a rigid and immutable way. Think email versus chat, both have pros and cons, but one is incredibly convenient while the other requires additional work. Blockchain networks offer 3 important characteristics essential to data privacy: security, immutability, and reliability. 1. Security. Due to blockchain technology's significant hype, many things need to be clarified about how this technology works. Specifically, people think a blockchain network is unbreakable or impenetrable because it is decentralized, uses encryption to secure data, is difficult to hack into. While all of these things are true, they do not mean that blockchain technology is unbreakable. Blockchain networks are secure, but they're still vulnerable to cyberattacks. Like any other system, security vulnerabilities may exist in the underlying code, or an outside party may tamper with a transaction. 2. Immutability. It can be challenging to impossible to change data stored on a blockchain once it is entered into the ledger, hence the word immutable. This characteristic makes it incredibly difficult to alter a record, considering the chain ID system is in place to ensure transparency. 3. Reliability. A blockchain network needs to be reliable and trustworthy, as it is one of the most widely used currency and data storage tools. Blockchains are known for their reliability and security. Still, some issues affect the system's performance, notably the high expense of some blockchain implementations, such as using a proof-of-work protocol. Best privacy practices for crypto users. Use a hardware wallet, If you plan to engage in cryptocurrency transactions, the most secure way to store your private keys is in a hardware wallet. This is a physical device designed specifically for the purpose. These wallets typically do not require the internet, which provides an added layer of security and privacy by isolating your keys from the outside world. Use a password manager. Using passwords for multiple accounts is insecure, and using one password across accounts can increase your risk exponentially. The best option is to use a secure password manager to generate and store strong passwords for every online account. You can also use this to generate a strong recovery sentence or phrase, which is a backup if your password list is lost or stolen. Use centralized exchanges with cold storage. Unless you're doing large transactions on an exchange regularly, exchanges should be used as a last resort. Centralized exchanges are convenient and easy to use, but offer little security or privacy. Instead, consider using a cold storage wallet that is not connected to the internet, which allows you to control your private keys. Use tokens with a privacy feature. There are a handful of tokens that offer additional privacy and storage features. The Bitcoin cryptocurrency, for example, can be sent over the Tor network and offers optional transaction mixers for increased privacy. This can be an effective way to obscure transactions from blockchain analysis software and services. Use trustworthy wallets only. Your wallet software is critical to the security and privacy of your digital assets. Several high-quality cryptocurrency wallets offer many features, including multi-currency support, mobile apps, custom client interfaces, and several wallet security options. Before deciding on a wallet to use for any given transaction, it's important to research the company publicly listed on major exchanges. Conclusion: how does blockchain support data privacy? New blockchain-based applications are launched daily, but many of these platforms are still in their early stages. As developers build new systems and figure out how to solve some lingering issues plaguing the technology, we will likely see increased adoption within the enterprise space. This could also encourage governments and other regulatory organizations to use blockchain technology. Companies in the public sector regularly consider the benefits of blockchain technology, particularly when it comes to cost savings, efficiency, and security. However, there are plenty of challenges before blockchain becomes a mainstream data privacy and protection solution. First, blockchains are typically structured to allow users to access the data stored on a decentralized network, which may or may not align with existing regulations.